Hey everybody, this is Games Plus James, and welcome back to our Unity RPG tutorial series. Now, previously, we just set up the basic game and got our character into the world, but he's just kind of frozen and static there, so let's give him a little bit of movement in this episode. So the first thing we need to do is, we didn't save our scene from the end of the first episode. So what scenes are in Unity is essentially your levels. Or in terms of this RPG game, our scenes will be our individual areas within the world. So what we're going to do is create one more new folder. So we go up to assets here and we'll right click and create a new folder, and we'll call this scenes, and then we'll go up here and say file, save scene as, and because this is just our main kind of like layout scene, we're just going to call this main for now, just to keep it nice and simple and fairly straightforward. So what we're going to do is, like I said, we're going to focus this episode around movement. And throughout this series, I'm going to try and keep everything nice and simple, so I'm going to be assuming that you're starting from the very basics of coding your own stuff. So we won't jump in and do anything too crazy and complicated straight away. We'll try and keep it nice and straightforward and simple. So, built into Unity, it has a system for handling controls in the game. If we go up here to Edit, and then down to Project Settings, and up to Input here. If we click on this, we'll get a new thing appear here in the inspector at the side. So if we click on axes here, we can see we've got a whole load of options. And basically they're all just a different setup for, or they're set up by default to handle keyboard controls and also controller controls. So we can see horizontal, so that'll be horizontal movement. If we drop this down, we can see you can press left and right on the keyboard, or you can press A and D to move left and right. Or if we go down to horizontal here and scroll down, we can see we've got Joystick Access, and Joystick Access is basically what's used on the controller. So that would be your left analog stick, for example. So then the same is true of vertical. We've got up, down, we've got SW, and then down here we've got up and down on the left analog stick. And then we've got a few different controls. We've got fire 1, 2, 3 and jump. So jump would be space by default, and fire 1, 2, 3. We've got like mouse 2 and left shift, all kind of set up by default for kind of standard controls that everybody uses. So they're very handy to use in that way. And we're going to use those for controlling how our character moves. So he'll be moving left and right and up and down. So we'll be using the horizontal axes here, and we'll be using the vertical axis here. And it'll all become very obvious as we go through it and start doing it. So what we're going to do is go into our scripts folder that we created in the first episode. We're going to right click here, go to create C# script. And we'll see we got a script here, and we're going to name this player controller. And one thing you want to make sure there's no gaps between your the words in the title of your script. You always want to, whenever you're making a new script, you want to make sure there's no spaces in it at all, and try and keep it the kind of basic way to remember the naming of scripts and stuff like that is for every new word in the script you use a capital letter. So we have player and we have controller, just to make it a little obvious that you can see where the word starts. If that was just a small c, you might mistakenly just think it was one big long word. It's not something you have to do, but it's helpful, and it keeps it nice and straightforward in your head. So we're going to double click on that, and we're going to open up here in Monodevelop. Now I'm using Monodevelop for this series, but in the Unity, the latest version of Unity, which is what we're using here, Unity 5.2, you can also use Visual Studio, which is extremely handy in general for coding. I prefer using Visual Studio, but Monodevelop has been the standard in Unity for a long time, so we're going to use that for this series. Visual Studio is a lot better for kind of auto-completing things as you're going along, but that's not very helpful when I'm trying to show you stuff here in the series, so we're going to stick with Monodevelop for now. Okay. So first thing we need to do is we need to know if our player is going to be moving. We need to be able to set what kind of speed he's going to be moving around at. And the way we're going to do that is just up here in between our line. This is public class and this little line here. So we're going to put a little bit of extra lines in. And here we're going to type public float move speed. So move speed has a small m because any kind of, what we're doing here is creating a variable, which is because we're going to be able to decide what speed the player is moving at. So we're able to vary that. So it's called a variable. Variable is basically anything that you can like put in some kind of input and affect it in some kind of way. Very broadly, basically. But we got move speed, and with any variable, what you want to do is start it with a small letter, and then, like I said, with every extra word going on, you want to say a capital letter to start that. So, what does public and float mean? So, a float is basically just a type of number. You have ints and floats. So we could also make this public int move speed, just for an example for a second. So if we had move speed as an int is basically a whole number. So it can only be like 1, 2, 3, 4, 150, 3070. There's no decimal places in ints. But in a float, it could be 3.5, it could be 167.3954, I don't know, whatever numbers you want, basically. So you just want to keep in mind, if you're going to be wanting to use decimal points and stuff like that, you want to use a float. And if you want to just have normal whole numbers, which would be used in different kind of cases, you want to use an int. But we're not using an int for now, we're using a float. And we've also got public here. So if we go back into Unity here, and if we go to our player, like this, and if we click and drag on our script and drag that onto the inspector over here, now we can see that this player controller script is attached to our player, which is what we want. We could also do this by going add component here and just typing in the first few letters of player controller, and we'll see we'll get an option here for it, and you can add it that way like that. But obviously we don't need two of them, so we'll remove that one. So we can see here now we've got move speed has appeared in our script, and the reason it's appeared like this here is because we set it to public, and public means that we can edit it and make changes to it. It's not just a hidden variable within Unity. If we were to set this to private like that and save, we go back in here, we let this compile down the corner, which is this little loop you see down in the bottom right here. Now we can see the move speed disappeared. So if we go back in here, that number hasn't disappeared from our script. We just can't see it, and we're not able to make any changes to it. So that's basically the main difference between public and private. Public means you can make changes to it from other places within Unity or from other scripts and things like that. But private means only this script will be able to see this value of move speed, and only this script will be able to make any changes to it. But we don't want that. We want to be able to set the speed of our character in Unity. So we'll set it back to public and go back in here. So now, if we have our move speed value, we can give that any kind of value we want. But our player, if we hit play, that doesn't magically make us be able to do anything. He's got a move speed, but if we use the arrow keys or WASD, we can't move around at all. So that's not good. So we'll go back in, and now we need to actually give him the ability to move around the world. And like I said, we're going to use those axes, the horizontal and vertical axes, to determine whether the player is moving. And basically what happens is, with those horizontal and vertical axes, it will return a number between 1 and -1. So if we're looking at the horizontal axis, we just pop it open here again. So if we're looking at the horizontal axis, so if you're playing left or right or A or D or anything, basically what'll happen is if you're moving left, it'll be -1, and if you're moving right, it'll be +1, and if you're not moving at all, it'll be 0. So what we want to say is, basically if the player presses the button down to move left, we want our guy to move left at the speed that we've set the player's move speed. And the same if the player presses right, we want it to move right with at our move speed. So we have a -1 and a +1. So basically we can just say if our move speed is 5, if we've got a -1 input, we can just multiply that 5 by -1 and the player will go -5 over to here. And similarly we can multiply the +5 or the 5 by +1 to move to the right, like that. And it's basically the same then for moving up and down on the y-axis. So basically all we need to do is we're going to use an if statement. And an if statement basically just checks and sees if something is true. So what we do is we say if, and then an open bracket, and then we use something built into Unity called input. So if input dot, and the reason we use a dot is to access functions within the input class of Unity. So we have input dot get key. Is it get key? No, sorry, no. It's get access raw. And we want to use get access raw because that basically takes whatever input is being pressed right at this second is what input we'll get. So we use input.get access raw and then another bracket and then some quotation marks and we say horizontal because we want to look at the horizontal axis, which is our character moving left or right. And what we want to check is if our input on a horizontal axis, so say we want to check and see if the player is moving right. So if the input on the horizontal axis is greater than, we know we want it to happen when the input is 1. So we'll say when the input is greater than say 0.5. Just, we don't want to say when it's equal to 1. We just want to say when it's greater than, we could say when it's greater than 0, but just to kind of break it up a little bit, we'll say 0 greater than 0.5. Okay, so then we use a little close bracket to close this whole little statement. So we've got input, so we're checking to see if the input is greater than 0.5. So if the player is pressing right. So if the player is pressing right, then we do an open curly bracket, put some space and use a closed one. So now we're going to write in between these curly brackets, we're going to write our bit of code that's going to actually do something. And if we just pop back to here and click on our player for a second, we can see here we've got a thing called transform. And transform is basically the position of the player within the world, the rotation, and the scale. So if we were to grab the scale here, for example, we could make him really fat and wide. That's not very helpful, so we just undo that. We can rotate him around like that, or a bit more. No, not like that. There we go. We can spin him around like that if we want to. Or what we're going to be using is we can change his position in the world like this. So we've got, to move him left and right, we're changing the X value of his position. But we've also got a Y value, which is up and down like this. We've also got a Z value, which we won't be using, but Z value is basically like how far he is into the world. So if we were to shift back to the scene view here, and we can see we're selected on 2D by default because that's the setup we chose at the start of the game. If we unselect that, we suddenly switch around to a 3D view. So we can see again, if we move left and right like that, we move up and down, and then Z will be moving in and out of the screen like that. Which is something, obviously, as a 2D game, we're not really going to be using that at all. Oh, didn't mean to do that. Press the wrong button. There we go. Okay, we'll pop back to 2D now. Okay, so we can see the transform in the world. So if we go back in here, we need to make a change to the transform position of our player so that we can move him left and right. So what we're going to do is type in transform dot translate. And what translate does is basically it moves the character a certain amount within the world. So we're going to, again, we're going to put an open bracket here. And within this, we can see we have this little pop-up that appears telling us what needs to go in our transform.translate. And what it's looking for here is a vector tree of translation. And translation is just the amount of movement that we want to have. But a vector tree is essentially a group of tree numbers, just an x, y, and a z value. So like here we have on our position, we have x, y, and z. A vector tree is just basically those tree numbers combined into one little object. So what we're going to do is create a new vector tree. And we need to give this new vector tree some values of how much we want the player to move. So we want to move our player on the x-axis, which is moving left and right. So we're going to do, as I said, vector tree has x, y, and z. So we want to make a change to the x value, which is the first one. So here we're going to say we want to base off how much our horizontal movement is being pressed, which is 1 or above a half at the moment, but it'll be basically 1. If that's true, then we want to say, okay, use the input dot get axis raw horizontal value, so that'll be 1 at the time. Multiply that by our move speed, which will be 5, so we'll be able to move our character around the world. Oh, I need a space there. Yeah. So this little asterisk symbol is the multiply symbol, and we also need to multiply that by a thing called time dot delta time, like that. And we're just going to close these brackets here, and then at the end of this statement, I should have said this when we created our public float up here as well, we need to put a semicolon at the end of any line of statement in Unity. So whenever you're telling Unity to do something, which is like what we're doing here, we need a semicolon. But we don't need a semicolon here because that's checking something else. But here we're telling it to do something. Here we're telling it to change the transform. Actually, I shouldn't have closed these yet, but we'll go back to that in a second. And here we're telling it to create something new. So this time.delta time, it's basically a function that creates a tiny little value. So within update here, which is where we placed all this code, update happens a whole load of times a second. It's based on the frame rate of how the system is running at the moment. So say we're running at 20 frames a second, then every 1/20th of a second we've got an update happening every single time. And the time.delta time is basically the amount of time between when the last update happens. It'll be a tiny little fraction of a second, so it'll just be 1/20th of a second, so that'll be 0.05. Yes. So basically, if we're running at 20 frames a second, our time.delta time will be 0.05. So what we're doing is multiplying that by the move speed and the input. And the reason we do that is because, say if we just go back in here to our game, say if you were running at say 20 frames a second, for example, and we had our move speed, and in one frame, if we didn't have time.delta time, in one frame we were using just the input access multiplied by the move speed. So in one frame we'd move from here to here, and the next frame we'll move from here to here, and next frame here to here, etc. If you have 20 frames a second, which is relatively slow and not something you'd want, say over the course of a second you would move from here to this amount. But if you were running at 60 frames a second, suddenly for the exact same amount of time, which would be 1 second, you would move 3 times the distance. So you would go from here all the way over to here somewhere, which is very inconsistent and not something you want to happen. So instead you want to multiply by the amount of time in between each update. So if you're running at 20 seconds or 20 frames a second, that'll be 0.05 of a second, and you'll only move a tiny little amount here. But if you're running at 60 frames a second, each frame will be 1/60th of a second, so you'll move a tiny little amount on each update, but overall over the course of a second at both frame rates you'll move the exact same amount. So that's why you want to multiply by time.delta time like that. Okay, so that's our x value that we put in, and like I said, we need to put in a y value, but we're not moving in the y axis at all, so we'll put in 0f, and we're not moving in the Z axis at all either, so we'll again put in 0f. And the reason we put 0f is because these are floats. Like I said, a float is a value that could be 0.7600 whatever. And if we look at transform here, we can see that they're all values that have a decimal point. So when you're working with your transform, you always want to use a float value. And to make sure Unity knows that this is a float, you put an F after every number, which is the same thing we did here. I probably should have explained that F when we did it up here, but that's what it means basically. Okay, so now we have our input when our get axis is above 0.5 is being applied here. Now, we could have it just being applied at all the times, because if we're on 0, then we're not having any transform translate being applied at all. But we'll stick with it happening only when the player actually presses some input. So then we're not doing some needless code when the player's just standing around doing nothing. And this works fine for when we want to move right. Actually, rather than just saying that, we should test it out. Anytime you write a new bit of code, you should always test it out. So we'll save that, we'll go back into Unity here. And now, once that compiles down the corner, we have it attached to our player and we have some move speed. So now if we press play, once it starts running, if we press right, there we go, we can see our character moving right. We can't move him back left, we can't move him up and down, but we can change his move speed and see how that affects it. If we slow him down a little bit, you can see he goes a lot slower, and if we speed it up a bit, we can see he goes faster. So there you go, that's our player. We can see it's actually working. So now we need to apply it to our other directions. So we'll stop that playing again, and every time you stop playing, your player, everything in the scene will reset back to the way it was, and any values that you change in the inspector either will also reset. So as you can see, it's gone back to 5 now, but we had changed it to 1 and 10, but it's gone back to 5, so that's perfectly fine. So what we want to say is, here we're checking to see if the person is inputting to the right, and we want to check and see if the person's inputting to the left. But if the person's inputting to the left, we want to do the exact same bit of code here. So rather than copying all this and rewriting it out again and just checking if they're moving to the left, what we're going to do is after our 0.5f here, we're going to put 2 vertical bars like that. And what that means in Unity is OR. So if input that axis horizontal is greater than 0.5f, so if a player is moving to the right, or if input, if input dot get axis raw again and horizontal, and close that bracket, is less than minus 0.5f. So if it's less than that value, that's when we know we're moving to the left. So basically here we're saying if the player is pressing to the right, or if the player is pressing to the left, then take that horizontal axis value, multiply it by move speed, and multiply it by time.delta time, and we'll be able to move left and right. So we'll go back in again after saving that, take another little look at the player, and he should be able to move left and right now. If we hit play, there we go. We can see our guy is moving left and right, just the way we want him to. Perfect. So again, we'll go back into Unity here. Now that we have that set up, and it's very straightforward, we can do almost the exact same thing to control the vertical axis movement. So we're going to copy all of that, put it down a couple of spaces, and just paste it in again. And we don't want to do the exact same thing, but it's going to be very, very similar. So on our input that get axis, we want to use the vertical axis instead of the horizontal one. And we want to do that on both of them. And we want to, obviously we want to apply the vertical axis down here. But at the moment that's set to apply to the X movement of the player, which is not what we want to happen. We want him to move on the Y-axis, which controls the player moving up and down in the world. So basically here we have it used as the X value, and then we have the Y value here, and then the Z value. So what we're going to do is delete the Y option there, and then before our input here we're going to type in 0f and then a comma, and now that's the X value, this is the Y value, and that's still the Z value. So we're going to save that, pop back in here, and now if we hit play, once that compiles down there, there we go, hit play again, and we should have our player move in every direction that he possibly can. As you can see, we can also, because we've set it up that way, we can also move in diagonals as well, which is kind of handy and dandy. Let's just make this like big and full screen here. So as you can see, our player can move around, but he's not very interesting looking. He's kind of floating around in the world. He doesn't really look like he's moving very much. So now that we've got our basic movement in place, in the next episode, we're going to take a look at adding some basic animation to the character, just so he looks like he's moving around a bit in the world and moving up and down and things like that. So, thanks for watching this episode. I'll be back soon with some more RPG goodness, and I'll see you all very soon. Bye. Thanks for checking out this episode, and if you want even more Games Plus James goodness, make sure you hit those subscribe and like buttons. You can also find me on Twitter and Facebook by following the links on screen, where you can find out all the latest news about the channel. And if you want to help support the show, check out the Patreon page, where you can get exclusive content in return for helping make the channel even better. Thanks for watching, and stay tuned for more.